Beyond the Hour of Code, Paul Hamilton, Matthew Flinders, Anglican College. So this is my school. Matthew Flinders, we are up on Buderim, on the Sunshine Coast, just about an hour's north of Brisbane. And today I'd like to talk to you. And I want to start by asking the question why. Why should we adopt coding in our schools? So what are the benefits of coding? We've been introducing coding in the primary school for a while now, and some of these aspects are really evident when we see our kids working. The first is the development of our higher level thinking skills. So if we actually look at when they're actually working, regardless of what platform they are, they're actually analysing and they're evaluating and they're testing some of these high level thinking skills that are coming through. The other thing that's interesting is the internal feedback that's actually given to them through the actual testing process. So when a student actually puts in a piece of code and then they test to see if it does what it's intended to do, it either works or it doesn't. And so the students are getting this continual internal feedback back all the time. And it happens through this testing process. The other thing that's really evident is the collaboration. We find our students that are working together consistently, asking for each other for help. How did you do that? Can you show me how you did that piece of code and what does it do? The creation aspect is evident all the way through because they're actually creating content as they go along. There's some habits of mind that are really evident as well. Habits such as persisting and actually when something doesn't work and actually fails for the first time, failure is actually a good thing, that we can actually go back and actually see what happened. And taking some responsible risks too, actually getting in there and actually seeing what different pieces of code does without a teacher coming up the front. There's some aspects of project management that are really good to see. For example, students asking other students to develop sprites and graphics and actually working together on the same actual task. And I guess there's no greater relevance for the 21st century than actually learning to code. We know that technology is driven by code and technology is all around us. There's been a real global movement in regard to coding. It probably in the US with code.org and the Hour of Code. We've seen a lot of high profile people promoting coding in schools. I guess a lot of it's come from the fact that there's going to be quite a lot generated as a result of learning to code. You can see here's the Hour of Code website, and we've got 36 million or so people, students have actually tried the Hour of Code. Phenomenal statistics as they go along. We can also see, and this is taken straight from the code.org site, that in the US alone, there's some pretty damning statistics about where the jobs will come from and how we've got a real lack of students studying computer science. And I guess this has spread to the UK with Hour of Code in the UK. The UK is actually really addressing this in their new curriculum as well, which is fantastic. And I guess as Australians, we need to jump on board as well and see the importance of coding in school. Okay, so how can we implement code in our schools without it being a threatening thing, without it being an add-on? How can we actually do this? Well, for a start, let's have a look in the environment. This is my primary lab. You can see here there's no rows of computers, very much a flexible learning space, places where kids can work together. But also they can actually write codes on all the walls. We've got some whiteboard paint there. It's just a really creative space in regard to students working together on projects and their different coding tasks. I created this little poster because at the start when I first introduced coding, I had this line of kids coming up to me and waiting for me to solve the problem. And I kind of worked out and came to the realisation that it was me as the teacher that was doing all the thinking and all the work, and I had to create, I guess, an environment and some structure and bring in some pedagogy that will allow my students to become the problem solvers instead of the teacher being not only the person that actually gave out all of the knowledge and information, but I wanted my students to be the centre of my classroom. So these are the couple of little things that I think a good coding program has. You can see on the right there my coding poster, the rules. I think one of the big ones is if you do come up to a teacher, you need to ask some really intelligent, smart questions. And what I found is when the students actually think about their questions, like, okay, my character's not moving in the right direction, when they're actually asking specific questions, they're actually half answering them in the construction of the question. So I think that's really important. So that is one of the things that I've did, and we've also got a really collaborative approach. A good coding program is obviously going to be developmental. It's going to actually have aspects right down to year one in prep where kids are actually exposed to logical, sequential thinking. And I'll go through some apps later on that actually can introduce that. Adopt it really early. When we adopt it early and we get kids thinking in this way, they can actually go a lot further along when they go there. We need to scaffold the skills, which is really important, but it's not just skill-based. We also need to teach concepts. I think there's some really important concepts in coding like repeat, the repeat code and how you can be an efficient coder that we need to teach. It's certainly a student-centred model and not a teacher up the front doing all of the talking and all the thinking like I mentioned in the past. It really needs to focus on the students actually getting up and presenting. I find in my class that the students are actually projecting and showing us code a lot more than I am, which is a fantastic state to be in. It's got to be collaborative and it's got to be cooperative structures and it's got to go across the curriculum. And I'll talk about that in a minute, about how it doesn't have to be an add-on, that we can actually build this into current curriculum frameworks. So this little example, I've got the YouTube link down the bottom. This is an example of a student that's actually created an ancient Egypt game as part of her study of ancient Egypt in the curriculum. And what she's done is she's created a game in GamePress. She's used quite a lot of code in her game. And what she's actually done is she's put her understanding, information, all her research on ancient Egypt into a game. And it's a platform game where the main character is actually being exposed to different things that are happening at the time, collecting food specific for that historical time as well. It's just got loads of information and it really does indicate that she's understood a lot about the unit. So we can actually introduce coding into any curriculum area at all. So some suggestions here. Look, when you're implementing a program, try and get as many people involved, including tech departments. We've got some coders actually in our tech departments. We may as well get them involved. Create little interest groups. Don't try and do it all at once. Really plan to do little snippets of coding from prep right through to year 12. Be flexible in your approach. But most of all, look for opportunities. Look for the physics classroom, the literacy, storytelling. There's some great opportunities to learn code with storytelling. The maths classroom. All of these have some really, really good elements that you can introduce coding into. There's definitely some obstacles there in regard to, teachers not thinking that this is important. Clearly it is. The whole Peter 12 and the filtering of some unbelievable online resources that we've got that I'll show you in a minute. I think the philosophy is one of the big ones in regard to teachers really struggling to see that our students can go past our knowledge base very, very quickly. And if you're a fantastic designer of lessons, if you're going to design your classroom so that the kids can really flourish and move at whatever speed they need to, that's what we need to focus on. And I think some teachers are actually struggling to find those cross-curricular links that we can implement. We've got some amazing resources here that are available to all sorts of operating systems. So there's just some simple applications that are available on Windows and Mac, Scratch, Alice, Kodi and Lego Mindstorms, and some different ones there that you might like to explore. A lot of schools are actually mobile now, especially in the primary schools. So there's some amazing resources on the mobile platform that you can use. Daisy, Bebot, Hopscotch is absolutely amazing. It's a 5-star app in regard to what you can do. GamePress is amazing. Kodi is probably much more in the upper secondary school that we can look at, and Hikitsu is just an amazing type game-based learning to code where the graphics are just phenomenal. So we've got some amazing different resources there for mobile. To be honest though, it's the online environment that you can really develop our students' abilities. CodeHS is amazing. It has a subscription base for your school, but the feedback and the support through that site is amazing. Codecademy, Khan Academy, Tinker and so forth, all wonderful, wonderful resources in regard to developing our students at the rate that they need to develop. So that's just a quick insight into coding and hopefully some helpful tips in regard to how we can actually get our kids coding in schools. I think the biggest takeaway I hope that you take away from this presentation is that the only wrong decision we can really make is not jumping in and having a go with our kids, especially in the primary ages. If we just sit back and think it's too daunting, see yourself as a learner with kids. See if there's some teachers in your school that can actually have a go at these types of things and actually get other teachers to come in and observe what you're doing. And the best thing you can do as a teacher is design really good lessons where you just give them the very basics and then allow for opportunities for them to talk and collaborate and just see how far they can actually go. Paul Hamilton here, signing off.